Alright, so this is the first video of our Unit 10 notes. And we're going to start by using guess and check to determine the answer for x. So this is 10 to the x equals 85. Now, what I encourage you to do is pause this, see if you can figure it out on your own. Try to get it to like 3 decimal places. Just to kind of give you a little bit of insight before you pause this here. I know a lot of times people will say, well, divide by 10 and we get x equals 8.5, but that's not correct because I know 10 to the first is 10, 10 to the second is 100, so if we want 10 to some power equaling 85, it's got to be between 1 and 2 for that exponent because 10 to the first is 10, 10 to the second is 100, so 10 to the first is a little too small, 10 to the second is a little too big, so it's going to be 10 to the 1 point something. So what I'd encourage you to do is grab a calculator, test it out, see what you can do, and then unpause it, and I'll kind of go through the same procedure. So here's what I would do. I would grab a calculator, and I would do 10 to the, and then let's try like 1.5, see what that is. So that's not 85. Let's try 10 to the 1.8 maybe. Still too small. All right, 10 to the 1.9. Okay, still too small. So then you can kind of keep doing this. I'll go 1.95. All right, we're a little too big, so now 10 to the 1.93. Ooh, that's pretty close, right? It's 85.11, but it's not exactly 85. So what's smaller than 10 or 1.93? So 1.925 maybe? Whoopsie. 10 to the 1.925. Okay, so that's a little bit too small, so we got to go a little bit bigger. 1.928. Ooh. 1.929. Okay, so it's got to be bigger than 10 to the 1.929. And so let's do 1.9295. Ooh, that's really close. So you know what, I'm going to stop there. We can get on with this lesson, but we're pretty darn close with 1.9295. And I'm going to write that down. X is approximately 1.9295. So here's the deal. Up until today, we have not figured out how we can solve for x in the exponent. All of the equations that we've solved, x has not been in the exponent. X has been down. We've had exponents like, you know, x squared or x to the third, but we have never dealt with x in the exponent. And that is what today's lesson is all about. So this is called logarithms. We're going to use a new mathematical operator called logarithms, and that's going to be kind of the focus of this entire unit here. So logarithms are another way to write exponents. That's it. 10 to the x equals 85 is the same as x equals log base 10 of 85. So what's really confusing to students oftentimes is what a log is, and all it is just an exponent. It's just an exponential equation written a different way. And the reason we need to do that is because we need to find a way to solve for x in the exponent. So to match these things up, 10 is our base on our exponent. It's also the base on our logarithm. X is our exponent on our exponential equation. It's what the log equals. And then it would be equals 85, so that's what we're taking the log of. So just kind of matching those things up. That's what you got to get really comfortable with logarithms, is converting it to an exponent and taking an exponent equation and converting to a log. So fortunately for our calculators, they are base 10. So if I type this in, log base 10 of 85, it should give me about 1.92, what was that? 1.9295. It should be around there. So let's grab our calculator and do that. It would be log of 85. So it's 1.929418926. It's going to keep going on forever and ever. So We got pretty close. I did 1.9295. It was off by just a little bit. It'd be 1.92942 approximately. All right. So the main thing for the first day on logarithms is, can you do this? Can you take a logarithm, write it as an exponential equation? Can you take an exponential equation, write it as a logarithm? Just kind of converting back and forth between those. So here's how we do this. If we have log base 4 of 16 equals x, if I want to convert this to an exponent form, I'm going to start down here with this 4, and that's going to be my base. And then I like doing a sound effect with this. I go, zoop. It is 4 to the x equals 16. So the 4, the base of the logarithm, is the base of the exponent. What it equals, x in this case, is our exponent. And then that would equal what we're taking the log of, which is 16. So start down here, zoop, around 4 to the x equals 16. So now we can solve this. This is really saying 4 to what power is 16? Well, I know 4 to the second is 16. So that tells me that x equals 2. So let me back up there one more time. This is really saying 4 to what power is 16? And I know that 4 to the second is 16, so that means that x has to equal 2. Okay, so let's practice a few more, and then we'll kind of wrap this up. I have our little power sheet up here for us to use, so we don't have to bust out a calculator anymore. This one is really saying, if I go zoop, 2 to the x equals 4. So this is saying 2 to what power is 4? And that is right up here in our power sheet. It'd be 2 to the second. So x would equal 2. On the next one, it would be zoop, 10 to the x equals 1,000. So 10 to what power is 1,000? It looks like 10 to the third is 1,000, so x would equal 3. So that's kind of the idea. You have to think, in this one, I'm going to get rid of the zooping. You have to think 10 to what power is 1,000. That's really what we're saying. So on this one, we're going to zoop it. So it's going to be 9 to the x, zoop, equals 1/3. All right, this one's a little bit trickier, because if I look at 9 here, I don't get 1/3 anywhere. So that's obviously not going to be super helpful. Oopsie. But let me think about this. I know that the square root of 9 is 3. And so that would mean that 9 to the 1/2 power is 3. We learned about that before, that the square root's the same as the 1/2 power. So we're closer, but we're looking for 1/3. And then the question is, how do we get that 3 on the bottom? Well, 9 to the negative 1/2 power would be 1/3. So in this case, x is negative 1/2. All right, if that was too much, rewind, rewatch, and hopefully it soaks in the second or third time. On this last example on this slide, we take the 7, zoop, 7 to the x equals 49. 7 to what power is 49? That's on our table right up here, and that would be 2. So it would be 7 to the second power is 49. All right, a couple more, and then we'll call it good. Why don't you pause, see if you can answer these before you rewatch it, and then hit play and see if you got them right. All right, so this first one, zoop, 3 to the second equals x. Well, 3 to the second on this table is 9, so x is 9. The next one over, zoop, x to the fourth equals 16. So now this one's saying what to the fourth power is 16. That means I'm going to be looking in this fourth power column. And it looks like 16 is right there, so it'd be 2 to the 4th is 16. All right, I'm going to clear off this. For the next one, this is 10 to the 5th equals x. So 10 to the 5th would be right here. That would be 100,000. And then the last one here, 27 to the 1/3 equals x. So this is saying this is really the same thing as the 3rd root of 27. That's something we learned back when we were looking at exponents. And the 3rd root of 27, well, let's see. We're looking in the 3rd power column. 27 is right there. So that means the 3rd root of 27 is just 3. So this would be 3. All right, so that's it for our intro to logs, day 1.